Hi, welcome to the Mentored Engineer. In this video, I wanted to show you why I created the Ultimate Beam Calculator and exactly how to use it. Alright, so as an engineer, I've often been frustrated with I have multiple loads on a beam and I have to go through a whole bunch of calculations just to figure out what the moment is at certain key points. So I wanted to make a calculator that would be able to do multiple loads on a bunch of different beam styles. All right, so let's get to it. So if you go to my website, mentoredengineer.com, and you either search for beam calculator or you type in slash beam calculator at the top. Once you get to the page, you can see that there are a bunch of different requirements of your beam. The first is the end conditions, which can be cantilevered, and guided. This is cantilevered on one side, but the other side has to remain vertical, so a slope of 0 degrees. Simply supported, this means that the ends can't move, but they can pivot. Fixed means they can't move or pivot. And we have supported and fixed, which is can't move on one side and can't move or pivot on the other. And then you have basically a simply supported case, but there's an overhang on it, which is great if you're calculating like a deck or something of that nature. So on each of these cases, you will see a picture pop up here. And you can see that, so it'll have exactly pictured what you have selected. At that point, you can type in a length of your beam, a strength of your beam. If I assume it's steel, I'm going to use 29,000 KSI, and I'm just going to make up something here. The Young's modulus and the moment of inertia are only used for deflection calculations. So if you don't care about deflection, then who cares? All right, and now at this point, we're going to start adding in loads. Now for our simply supported case, we have the most loads here possible. First one is a point load, and that's just a load at any given section. We have a constant distribution. We have a distributed segment, which only exists over a certain part of the beam. We have a linear increasing distribution, a linear decreasing distribution, a pyramid distribution, a moment at one end, a moment on the span somewhere along the length of the beam, and moment at both ends. So I'm going to show you some of the bigger ones here. The first one I'm going to do is a point load, and I'm going to click add, and it's going to reload. You notice it still kept our supported thing, and now it's asking me for two different pieces of information. I need a load and a distance from the left side. Alright, so I'm just going to say it's 34 inches and my load is 1,000 pounds. I can go up and hit calculate. And it'll make some calculations here. And I see that output right here in this table. So there's a couple things in here that we want to check. It's going to pick each length of the boom, each length of the beam. It's 0 inches and 100 inches. And I should see here that my moment is 0 inches, or 0 inch pounds and 0 inch pounds, because those are pivoting and they can't take moment. My deflection should also be 0 because it should not deflect. Now if you look here, the 34 inches is where I placed the load, but there was also selected a 45.7 inch location, and that just happens to be where the deflection is the most. Alright, so it knows from these cases exactly how many points of interest there are in these beams. Alright, so I'm going to add in another load case, and this will be a constant distribution. And since it's constant, it's only going to ask me for one piece of information, which is W, which is just our load per inch. So I'm going to make that 50 pounds per inch. And I'm going to go up, and all of our stuff is the same here, except another line was added at 50 inches. And you can see at 34 inches and 50 inches, my deflection actually went down a little bit. And right here, I've got the load case 2. I've got 0, I've got the 34, the 45.7, 50, and 100. And I can see that at 50 inches is my maximum moment for this case, and it deflects 0.45 inches. So this is the heavier load of this beam. Now down here, it totals it. So I have both cases put together. So at each end I still have 0 inch-pound moments and 0 deflection. But as I go closer and closer to the center, I now have the sum of the previous 2 cases put in here. Now I can go on and do this for as many different things as I want. I'm going to put a moment on the span. I'm going to add that. So here's the moment on the span. And I'm going to enter in, let's just say 6,000 inch-pounds, and it's going to be at 74 inches. We actually added some points in here of interest. This one right here, 51.55, is a point of interest because it has the most deflection. We also have 74 because it has the maximum negative moment, and 74.01 because it has the highest positive moment. And we can go down here and just see that these still add together, and we have our final results. If you want to add more points of interest to this, you can use a point load and just put your load of like 0.1 pounds at the point where you are interested in the load. Most of them should already be there and calculated, but there are some combinations where the deflection might not be the highest that you want to look at, just because of how the loads interact with each other. But it should get you close. All right, well, I thank you for using this calculator. It has been a godsend to me, and I appreciate you watching this video. Thank you. Have a great day.